All right, so last video, we talked a little bit about what chemistry was, what measurements are, and what scientific notation was, did a few examples. And so now let's actually get into significant figures. Again, I shorten this down to Sig Figs. So what are Sig Figs? Sig Figs are all digits that are known plus a guess digit. Now, if that makes no sense, that's fine. You will have practice in class with this, as well as reading through some rules and getting to know this more. The number of your significant figures and the number of significant figures you have totally depends on what instrument you're using for the measurement. So the more precise an instrument is, the more known digits you will have. The less precise an instrument, the less significant digits you will have. It just depends. So we're going to have 5 rules for determining how many significant figures there are in any given measurement. These are actually pretty tough rules to follow, and it really does take time and practice to figure them out. So again, I suggest writing these down, but if you don't understand them right away, give yourself a chance. Don't just shut down. So our first rule is that every number that isn't 0 is significant. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9 are all significant. Our second rule is that if the 0 is in between non-zero digits, it is significant. So let's see if I can write this at the same time. I like to call this rule the sandwich rule. So we act, did I spell sandwich right? Okay, yes I did. So this is our sandwich rule, which basically means that your bread is the non-zero digits, and you can have as many zeros in between. So a great example of this would be 101. There are 2 non-zero digits on the end, and there is a 0 in between. That's obviously very, very sandwiched. So right here, we would have 3 significant figures. Let's see if I can fit that in there. So 3 sig figs. If your number, however, was, let's say, 110, that 0 is not sandwiched in between. It's just kind of chilling at the end there. So this one only has 2 sig figs. Again, if you are confused right now, that's totally okay. We're on rule 2. Okay, so rule number 3 is a little bit convoluted. It's kind of a lot here. So when we're dealing with decimals, the leftmost decimals before non-zero digits are not significant. They are just placeholders. So I'm going to try and write that maybe a little bit more clearly and see if this helps you guys. So basically, this is the rule of leading zeros. And when we say leading, it means they literally lead up to your first non-zero digit. So, leading zeros. And basically, just so you have it again, it is zeros that lead up to a non-zero digit. We do not count them as significant. So let's do a few examples and kind of really define what we mean here. So, if you guys were given the number 0.00030, actually, let me take out that last 0 really quick because we haven't gotten to that rule. So if you were given this number, do you see how all of these zeros are leading up to our first non-zero digit? So that means none of them are significant. This little guy only has 1 sig fig. Give it a second. 1 sig fig. Now, if you were given 0.42, that first 0 is leading up to the 4. So it does not count. So right now, that's just 2 sig figs. Whoops, let me go back there. So again, first example of them. Let's see if that makes sense. All right, so the reason I erased that 0 after the 3 in the first example right there is because we hadn't gone over rule number 4 yet. So rule number 4 is zeros at the end of a number and to the right of a decimal are significant. So I'm going to redo that little example. So now if we do this number right here, very similar to the one we did in 3, there are 4 zeros still leading up to our first non-zero digit. Cool, those are still not significant. But now we have this 0 after the 3. So I'm going to make it a little unique there. It is not only to the right of a decimal, but it also is following a non-zero digit. So for this guy, we actually have 2 significant figures. So our final rule for significant figures are trailing zeros are not significant unless they are a known measured value. So that's both a no and a yes in here, and it's kind of confusing, but we have something that is super helpful for letting us know actually, in fact, this is a known value, and that is simply a decimal. We also tend to show that these zeros are significant by changing from normal notation into scientific notation. All right, so let's do a few examples of these trailing zeros and how to show that they are significant. So I'm going to give 3 different examples. All right, so here are 3 different examples. Right now, this first one only has 1 significant figure. But let's say this is an absolutely known measured value. It would be shown that it is all known by having a decimal place at the end. So this guy has got 3 significant figures. I'm going to shorten it down by saying SF. So this guy's got 3 significant figures, but it is a little weird to write it just 300 decimal. That's not super clear all the time. So the way that you want to write it is you want to transform it into scientific notation. So remember, our coefficient, our big number out in front of the times 10 to the, has to be a number between 1 and 10. This one's really easy. We just have to put a 3. But if we just had a 3, that would only be 1 significant figure. And again, this guy's got 3 significant figures, so how do we show that? Well, we move the decimal over and include the zeros. We say, well, this is 3.00 times 10 to the, and we moved that decimal over twice, right? So times 10 to the 2. I'm going to make that a little bit clearer. And so that's how we would show it. And then, of course, include our units. So for the second one, again, let me add the decimal in so you can fully see it. And this guy here would have 4 significant figures. Because it starts with a non-zero digit, our zeros are all trailing our non-zero digit, but that decimal right at the end makes them significant. And then, just as added practice, let's transform that into scientific notation. 9 has to be our number because it is between 1 and 10. We keep all those zeros and say these are significant. We have 4 significant figures. And then just multiply it by 10 to the 3rd. And now on our final one, I added this in just because it's a lot of non-zero digits. But I'm going to put that little decimal there and say, hey, every single one of these numbers is important to know. So for this guy, we've got 2, 4, 6 significant figures. And because, it's relatively easy to see that all the things are significant, the decimal's not super crazy, we don't have a ton of zeros, you can actually keep this one in normal notation. But if you did want to challenge yourself, you could transform it into scientific notation. This one would be 2.75630 times 10. And this time we moved our decimal how many places? 1, 2, 3, 4, 5. So you'd put the 5 up there. You'd remember your units because I'm doing really bad at that right now. And then you would be good. So in order to keep this video a little bit shorter, I'm going to stop us right here. Now, that is, quite a bit of text, really. But those are what significant figures are. Here are the rules. You need to understand this from this day forward, basically until our very last day of class. I will always award points on tests for significant figures, and it really does change whether your answer is right or wrong. Our next video is going to cover what are the rules when adding, subtracting, or multiplying and dividing with significant figures.